Alright, now let's talk about some tests. When we compare two groups, there are some different kinds of tests. Depends on the situation. So, for example, for some reason, you don't use some interval or ratio because you messed up, or because of the nature of your study. In that case, you cannot use a more powerful test. You need to use this test called chi-square. Chi-square can be quite popular as well, but it's not as powerful as the test that we are going to talk about next. But uh, okay, for chi-square, it compares the frequencies. So, for example, suppose you ask this question: how many men versus women will say yes to cheeseburger? Right? You will record the number of men say yes to cheeseburger and the number of women say yes to cheeseburger. And this is the only frequency. There's no like a mean, standard deviation, whatever. Just frequency. How many people say yes? So in that case, you will obtain the frequencies. It's O, and frequency obtained in the experiment, that is O. And then you also have this expected frequencies. Um, that is E. Okay. If the null is true, what do you expect to find in terms of frequency? So, for example, you ask 10 men and 10 women, right? How they will say yes to cheeseburger. And uh, so let's say 5 men say yes, and 4 women say yes. Yeah. Now, if it's the null is true, you will expect they should be the same number, right? Either 5 versus 5 or whatever. And so you test the null. If the difference is enough for us to say it's a significant difference. Okay. This is just for idea, to for you to understand. There's a chi-square and its testing frequency, but we're not going to use that. um, it's not very powerful, compared to parametric test. Um, so if you can use a parametric test, don't use chi-square. Alright, how about this? If we use some interval or ratio scale, then what we use is t-test. Uh, Actually, I probably need to be a little bit more specific. T-test is when you have two samples. Okay. There's another situation when you have a population and a sample. Then you don't use t-test. You use something called z-test. But you don't have to, get into that. Just remember, when we have two samples, we use t-test to compare the difference. Okay. Now t-test has something called distribution. Just take a look. It's a function of a sample size. All right. But you don't have to worry about this. Okay, you can take a look. I mean, this for those who have taken my statistics, this is kind of like a review. If in any case you haven't taken any statistics, um, uh, you are going to come across this. All right. This is just a very quick summary how to write the result for t-test. This is pretty much a standard way of of reporting. You can say we performed independent samples t-test. That is if this is a between group design. Okay, two groups of two different people. You compare the means. So you say independent sample t-test to test whether there was significant difference between men and women on height. Okay, suppose that your DB is high. And the results suggest the mean, and you need to specify the mean and the standard deviation. And watch those are italic. Uh, you report it, and then were significantly taller than women, and then you report it. And then this is how you report T, and then parentheses, and then there's a number. This number actually is the degrees of freedom. And when you use some software, pretty much is SPSS, uh, use this software to analyze the data. The software will tell you the degrees of freedom. Okay, so equals 5.62. This is a t statistics. Again, the value will be reported by the software. And then this is p-value, equals to 0.01. And you can see this p-value is less than 0.05. That's why we say it's significantly taller, right? Okay, and then you explain what this means. Therefore, male participants in the study were significantly taller than female participants.